let's go ahead and start rolling, y'all. Okie dokie. All right, so I'd like to welcome back to the stage Mark Gibson with Fun with Pinball and David Volansky with the Pacific Pinball Museum, here to tell us all about the intro to electromechanical startup sequences. Take it away, y'all.
Thanks. We haven't figured out who's going to say what yet, so I guess we'll.
1, 2, 3, shoot.
Yeah. Good morning, everybody. Thanks for coming. Let's talk about objectives. The the impetus for this talk is there seems to be a lot of people out there who will ask a question online and say, "My game won't start. The motor just keeps running. What's wrong?" And they think that there's sort of this answer we can give. And in the next hour, we'll tell you some of all the different things that could be wrong. And so kind of going through what happens in the startup sequence, what all the different variations are, and look at some of the troubleshooting steps for getting through that.
So it's a maybe an oversized topic to try to cover, and so we are not going to address a specific game. We're trying to hit common features that you'll run into rather than working through the complete sequence of any one game. So these are the kinds of things you're going to want to evaluate as you're troubleshooting a reset.
So we're going to focus on electromechanical games with score reels. We will talk a little bit about earlier games that have what's called light box scoring, but mostly we'll deal with the score reel era. We will look at and talk about different manufacturers in different eras, but again, we have examples, but the idea is to stay general, and because every game is different. You might have two games adjacent at the same made at the same time by a factory where there's some more commonality, but really, I pull a schematic out every time, just about, because things are different. No one reason, there can be a lot of different things that are causing the problem. We'll cover a lot of different ones. And of course, it's a really complicated process. There may be more than one thing that's broken. I mean, if your game was working yesterday and now it isn't, it's probably one thing. But if you're working on a project and it still won't start, it might not be just the one thing you're looking for. You may find something and it still doesn't work. You're going to look for more and look for more.
Mm-hmm.
And I like to talk about this cruel irony of learning EM repair. A lot of people, they'll get a project game, and before they've done a lot of work to it, they're going to plug it in and hook it up, and it won't start. And to get it to start, you only have to learn just about everything there is to learn about EM repair to get it to that point. So if you just want to get started, it's often better to get a working game, have one thing fail, work on that one thing. Hopefully the thing that failed isn't startup. But really, you're going to cover almost everything in the game that isn't on the playfield, and sometimes things that are on the playfield. But it's involving relays, motors, steppers, score reels. All this stuff has to be working correctly for startup to complete.
It's typically, or often, among the most complicated sequences your game has to accomplish, right? Particularly if you're looking at a multiplayer game, you hit that start button and it takes much longer than any event that happens as you're playing that game, with possible exception maybe counting a bonus or something like that. But it's a tremendously long sequence in relation to the other things that your game has to accomplish. Commonly required startup events. So we're going to cover a lot of these individually, but this is sort of a shopping list of the kinds of things that you're going to see that are going to have to happen successfully as the game resets. Starting with a replay button, which will typically fire either a relay or your score motor. They're starting credit and start relays, lock and hold relays are the kinds of things that will be the first things to fire in your game. Everybody's familiar with the score reels that have to reset back to 0. That's always seems to be a common troublesome point, probably because there's so many score reels, right? You might have 1 or 2 steppers that have to reset, but you might have 3 or 4 score reels that have to reset. Wood rail errors that uses light bulb scoring, they have steppers inside that need to reset as well. Ball counts, coin units that keep track of how many players have paid, those all need to reset. Why don't you finish that?
Yeah, we'll probably talk about we will talk about all of these again. This is kind of a high level overview. Let's see, you were. We'll get into each one of them. And this last point about feedback is something we're going to dive into a little deeper. When you fire off the startup sequence, there are a bunch of things that are going to get reset. Score reels are going to get reset. The bonus units are going to get reset. Coin unit. A lot of those have a switch or something that the game is going to use as feedback to know it accomplished its reset. And a lot of them don't have feedback. So when the motor just keeps running, it's usually not gotten the feedback. Now, something may not have reset, or it may have reset and not closed a switch that sends the feedback. That's 2 different problems. But a lot of times you have a multiplayer game and it keeps starting in 2-player. That may be a reset of the player unit that doesn't give feedback. It sends a reset pulse and doesn't wait. So we're going to talk, as we're talking through, about things that do and don't have feedback and how they come up as different kinds of problems. And this is sort of like an agenda slide for where we're going to go with the presentation. We're going to talk about how you start the sequence. It fires off some relays. Those relays tend to get the motor running. And with those relays engaged and the motor running, other actions will now take place, including resetting stepper units, resetting score reels, and resetting other things that need to get to that sort of 0 state for us to start. And we'll have time permitting, we'll have a nice deep dive into the Gottlieb player unit, which is the Gottlieb multiplayer sort of system manager even. I've never thought of it that way, but it keeps track of a lot of stuff that's going on, and Mark did this amazing sort of breakdown of what's in there, so I'm hoping we'll get to that. Anything else in this?
No, this is just a tour. So we'll often get a question online or in the clinic, I've got this new game, I hit the start button and nothing happens. I have credit, so it must start. And sure, it should, but it's not, just the switch behind the door that's not working. There are things that have to react to that, and maybe we'll go to the next. We'll have examples on the next slide here, but typically, your start relay or your reset relay will have to respond to that coin, or your coin relay will have to respond to that replay button that you've hit, or the coin that you've dropped. And one of those will start the score motor running, which will get the ball rolling through your reset process.
I'm going to take a little break here before we go to the next slide. You mentioned the clinic. Let me do a little commercial break here. Mark organized something that we started during COVID, but have continued them. We've gone ahead and continued them about every 3 or 4 weeks, and they're not pre-announced. Like, we figure out if it's going to work for people's schedule. And you can sign up for these on the Fun with Pinball website. Is it funwithpinball.com? Okay. People sign up who have a game at home with a problem, and technicians sign up we use the term coaches in that setting. And we also have a lot of spectators, people just wanting to learn in those sessions. So they're not recorded, it's live. It's a platform similar to Zoom. It's called Jitsi. It's free. Everyone will have access to it. And we talk people through solving their problems. We're often on these sessions for like 3 or 4 hours. They tend to be Fridays at 3 p.m. Pacific time, but we have people from all over the world joining. We have a regular from Germany who's on at like 1 or 2 in the morning, and we answer his questions.
And one of our coaches is from down under in Australia, so we've got several continents dialed in at the same time, which is really cool.
So we'll talk some more about how to find it on the funwithpinball.com site, but for now, let's just continue on.
So these are all examples of where you might start. Okay, so my start button or my credit button doesn't work. Well, notice that if the objective here is to fire one of these coils, for example, the first one here, if I wanted to fire this coin relay to get the ball rolling, right? Well, my credit button has to work, but so do all the switches behind it, right? There's 4, 5, 6 switches typically in a circuit that have to all close at the same time or be closed for that credit button switch to do anything. And the credits are going, the circuits are going to vary from game to game and manufacturer to manufacturer, but just be aware that there are many things between that button and getting the game going, right? So you may have cleaned that switch, you may have replaced that switch, you may have studied it, and the switch may be perfectly fine. It may be somebody else in that circuit, right? But they're all going to be somewhat similar, right? There's going to be a number of things that all have to be closed to get you going, to get you started, even if you have credits, right? The credit unit is just another switch in this chain.
And one thing to notice about these examples, and we didn't even include a Gottlieb, which we'll talk about. In all of these examples, the coil that's getting fired off as a result of all the switches being closed and hitting the credit button, it's not even the same one on all these games. There isn't a term for what that coil is. It might be coin, it might be credit. What's another? We have 2 different ones called credit from different manufacturers.
Start, replay.
But yeah, it could be start, could be reset, coin, credit. And in a lot of cases, I've seen where the coin relay then fires the credit relay. There's sort of this cascade that gets the game in the state it is in for completing reset. A bunch of relays trip. And one of those, or multiple of those, will probably start the motor, which we'll get to soon. Wanted to talk a little bit about the Gottlieb sequence, because I think Bally and Williams will usually just fire off some relays that stay locked on. I don't know that they do as much of using interlock relays or trip bank. They probably do. Again, I don't keep track of all the different games and eras. I just work on the game in front of me, and I know there's not going to be one solution. There's commonality. The thing that I wanted to do about trip bank, and we're talking about the SB armature, but Gottlieb has an interesting sequence on some older games where when you start reset, a relay on the trip bank will trip. And trip bank relays, they get energized for a very short time, and then they change state, and they stay in that state until the whole bank gets reset. Gottlieb has this sequence where they trip something on there, and it may trip more things to get through reset. And at the end of reset, the trip bank gets reset. So it's kind of interesting. They start reset by tripping something, do a bunch of work, and when it's all done, they can reset that. And that's something you want to kind of understand, because people often ask, what is the state of the schematic and all that? You want to kind of understand that, but you also want to realize, and maybe look while your game is working, when you hit the start button, there's something on the trip bank that's going to trip, a bunch of stuff is going to happen, and then it's going to get put back into its reset position.
Something else to be aware of is shown on this schematic. This circuitry is running at 120 volts, right? This is the power plug in the bottom right corner, and it's feeding right into the transformer. And some of the circuitry is in the 120 volt domain, right? We didn't show it in the previous slide, but often that coin switch behind the door is also running at 120 volts. So be careful, particularly working on a game that you're not familiar with, that There's going to be live mains voltage running around through there, not just safely tucked in the back where the transformer is. It can be peppered throughout your game. But this SB armature switch that's circled here, this whole bank can be reset with a single pulse from the score motor, but it's dependent on a switch called the SB armature switch, which confuses a lot of people, and it's hard to adjust. And if you've never seen one, this is where it lives. This is the underside of a trip relay bank.
This was something that was actually out of a game, and usually you can flip these up, and you still you'll never get this good a view of that switch while it's in your game, unless you were like this tall and kind of climbed under everything.
So the switch is mounted to the bottom half of this trip relay bank, and it's hard to see, and the issue is that it has to work properly in a setting where you can't see it. So the whole rack does rotate up so you can see it and adjust it, but once you flip it back down again, you can't really see if it's operating properly. And it's running at 120. You'll notice the plastic-coated wire. That's kind of a clue that it's running at 120. But this thing needs, typically on a Gottlieb game with a reset bank like this, needs to be working properly, and is the cause of a lot of issue because people can't adjust it and then put it back and readjust and put it back and can't get it dialed in properly.
And to make sure you're seeing where this is, and if you could point, because if I turn away from the microphone, it doesn't pick me up. So behind this bracket is the coil. And the coil, when it energizes, it pulls in this armature, and the piece above it falls down and changes all the switches. And all your trip relays work that way. The SB armature switch is a special switch that's leaning up against that first piece that trips. It's separate from all the other switches. And when I've asked Gottlieb engineers why this was developed this way, they say it has to do with the timing and that this switch needs to change state later than all the others. They wanted to make sure the switch opened only after you're completely reset. So it's tucked under. I have had this be the cause of startup problems. So there are times you just have to get down to it. And God, just even looking at closed versus open, it is hard to see. These blades are bent kind of funny. I would clean all that up if I might not even look there if things were working.
Right.
Right.
Don't adjust it if you don't have to, right?
And again, 120 volts are running, 110 volts are running here. I will unplug a game to work on that. I don't just depend on the on-off button.
And you'll often see a rubber stopper beneath this switch that's resting up against the armature.
Where are we?
That is often, if that's missing, right, you may have 120 on your entire trip bank as well.
Oh yeah.
So be careful with that.
Good point.
Have we beat that enough?
Yeah. So another style of relay that you're often going to be looking at as part of a startup sequence is an interlock relay. So an interlock relay has two coils. So instead, most relays will have just one coil. It energizes, changes state of the switches for a while, and when it de-energizes, the switch states turn back to their resting position. With an interlock relay, you fire one coil to change the switches into one state. You fire a different coil to change it back. Neither coil needs to get energized for any length of time. It just gets a little pulse. And they're not used just for startup, but the state of those switches can sort of carry over when you turn the machine off and turn it back on. It's going to stay in whatever state it was in unless something else in the game is going to switch it right when you turn it on. This example is showing how the startup sequence uses a game over trip latch relay, but a common one that causes problems in startup, I told you how Gottlieb did this sort of trip bank. It trips it, and then when it's done, it resets it. they wanted to get away from using trip banks in general, and people often have heard about the AX relay, and people think of it as the dreaded AX relay. Particularly later EM models, the throw of the switches is very small. You've got to get things adjusted just right. There's not a lot, it's not moving as much as other relays. And that relay is going to change state at the beginning of startup and then change back at the end. And it's going to use two different coils, and it's getting energized two different ways. And this is a reasonable example of seeing something like that.
Yeah, so I mean, the dead giveaways, there's a big switch here in the latching circuit on the reset relay, right? So this is something that does have to happen during reset. And the lower part of this schematic is what happens during the game when this thing would trip. But it's the top path that's used during the reset sequence. Okay? So score motors eventually are going to get involved in reset in most games. The score motor is going to drive a lot of the sequences. It's going to throw pulses out at your score reels, for example. And it often will keep running until it has gotten or the reset circuitry has gotten the feedback that we talked about, right? So parts of the reset circuitry are going to wait to hear back from score reels and other things. And we'll keep that score motor running until they've heard back from all the devices that it needs to hear from. The side benefit of having that resiliency is that if you have a sticky score reel, sometimes the motor will get you through the reset. It might take a few extra tries to get it back to zero. But the fact that it's waiting to hear back keeps it, so it makes the game a bit more resilient as it's waiting for service, right? And often, the complaint is my score motor won't stop running. Well, typically your score motor is the victim in that situation, right? He's just the guy trying to do his job. He's not heard back that he can stop yet, right? So the score motor running is more of a symptom that something is wrong rather than the cause of the problem.
Yeah. One thing I always like to include in discussions when I talk about the score motor is when you're looking at the score motor, and the diagram here is
a Bally.
That's a Bally.
motor.
And Gottlieb's got a horizontal there. Essentially, you've got a bunch of cams that are going to change the state of a bunch of switches as the score motor is turning. Every switch but one there is dependent on some other switch in the game to do something. In other words, if nothing else in the game has been energized or put into a special state, you can sort of turn the motor by hand, and you have to just sort of start it going. One switch on the motor will make it always stop in the same home position. And there's more than one home position. We'll get into that differently. But there's one switch there that by itself will run the motor back to its home position. All the other switches only do something if something else in your game is in a state where it's going to use the score motor to get some work done. So, during startup, let's see. If the motor's running and nothing is happening, it's because another switch is not closed. You're probably not looking on the score motor. No, you could have a score motor switch that isn't closing and isn't kind of getting the work done either. But usually it's running because something else hasn't finished. That's kind of the point of that. Mm-hmm. So now we get into the resetting of stepper units. So at this point in your game, you've hit the start button, some relays have tripped, the motor has started running, and other things are going to get reset. That's kind of set the stage. So looking at stepper units, a good example is the ball count unit. You need to get to where the game is going to start. In a lot of cases, it's just like a regular replay game. You're going to set the ball count unit back to 0 or back to 1, depending on the manufacturer. It's a single pulse sent to a coil. It'll go ahead and reset that unit. And I think in most cases, it's got feedback. It's one of those things that the game is going to stay in reset until that is actually accomplished. And there's a post with a switch on the back of the unit, it's probably not on the wiper, that tells it it's done. If you want to talk about add-a-ball.
Well, we'll have an example of add-a-ball.
Okay, so we'll show that, but in add-a-ball games, the stepper operates differently. It's going, during startup, it's going to not like suddenly reset, it can't do that. It's going to step down to 0, and probably at the very end of reset, I think it then steps up to either 3 or 5, depending on how you've set your how you've set your game. So for add-a-ball games, you've got this step down, step up stepper for counting balls, because you can start at 5, you go down to 3, and then you've earned another ball, it'll go back up to 4, it could go back up above 5. So you've got this stepper that goes up and down, whereas on the other games, it's just gonna start at 0, and it's gonna count up to 3 and then end your game, or count up to 5 and then end your game. So there's a big difference between those two and how they work in reset.
So this is just a trivial example of a ball count unit. It's a simple stepper. This particular one resets completely back to 0 from any position when it gets a reset pulse from the score motor. In the circuit here, you'll notice it's driven by a score motor switch that's in the red box. And it's dependent on a switch on the coin relay, which is one of those relays that fires as soon as you hit the replay button at the start to get the ball rolling, to get reset started. The other stepper in this schematic is not shown. I mean, it's shown in the schematic. There's not a diagram of it. The replay unit is something else that will have to take a step down. It doesn't step all the way back to 0. It doesn't take all of your credits away. It just takes a single step backwards as part of reset.
And one of these is actually going to step up, the total play meter.
And the play meter goes in the other direction.
Yeah, I mean, it doesn't step down ever, but it's just, it gets a pulse and it adds to the meter there. Mm-hmm. But recognize, and it's a little bit uncommon that switches are going to drive multiple pulses out of a branch. There's usually discrete, but here's one of those cases where these two switches are going to make those 3 things happen. Good to notice, if one of them isn't happening, don't have to go look at those switches. Those switches are working if 2 of those are working and 1 isn't. You might have a mechanical problem. You might have a broken wire, bad coil. You know, I always take advantage of when there is a branch to say, if these 2 are working, I'm looking at the 2, let's say 2 of the, if my play meter's moving and I'm decrementing credits and I'm not resetting the ball count unit, it's not the switches. Start looking at wires, look at the mechanics of your ball count unit, stuff like that.
The game has all kinds of built-in troubleshooting features like that, right? Leverage these things as troubleshooting or diagnostic tools, right? Because they're wired together. But this is the example we mentioned of add-a-ball units. So there are 2 coils here shown. One is advancing the ball count up, and the other one is stepping it down. Well, as part of the reset, this thing has to step down all the way to 0. From anywhere, right? You might have unplugged the game or tilted the game, and it will count down to 0 before the make-break switch flips to the other side and counts the balls up to 5 as part of reset.
So looking at another kind of stepper that needs to be reset as part of startup sequence is your bonus unit. These are typically mounted on the bottom of the play field. And in most cases, they're going to do a step down function. So there's a lot of pulses getting sent out. So if your bonus was high and your game ended because usually your game ends and you count off your bonus and it's going to be at 0. But if you've tilted or turned off the game, your motor's going to run a few cycles just to get the bonus unit all the way down to 0 if it has a lot of bonus built up. It was only at the very end of the EM era that, I think I know of one game, that added an extra coil so that your reset, you can reset your bonus unit with 1 quick pulse. Grand Prix does that. I'm not sure that I know of other games that did that. It's an unusual sort of a convertible stepper. You can make it step down, or you can make it a full reset with an additional coil being energized. But in most cases, lots of pulses are going to be set to the bonus unit to get it down. And this is one of the units that'll have feedback almost always. There is a switch that the reset sequence is waiting for that shows the bonus unit got to 0. I don't think we have that in the
That's actually in the schematic here. So if you look,
okay, good.
the top half of this drawing is the circuit for the bonus relay. And there's a switch here on the reset relay. So this path is being used during resetting the game. And it will fire that bonus relay and keep it fired until the bonus unit reaches 0, right? That's the feedback. It's waiting for that thing to count down to 0. It doesn't know where it is, but it knows when it gets to 0. And with this bonus relay active, I can now, we'll close this switch down here, and these score motor switches are going to send pulses through to step that bonus count down. And it will take as many pulses as it needs and wait until this 0 position switch opens, and that's when this part of the reset will be done. Was there a
Yeah,
question?
there's a question. Let's get a microphone to you if we can. Otherwise, we'll either repeat your question or we'll give a. Sure. Oh no, I entertain questions throughout. If I think you're.
I just wanted to actually make a comment. Thank you so much. Thank you. I'm sorry I'm late and I didn't even see the instructions. But I was going to tell you there's an absolute example of what you're talking about right over there in the other room called Skylab. It has this. Like if you want to just go see after you're done talking, anyone here? Go look at Skylab. It's got the 5-ball system that you're discussing. It's in 100% working order. It's beautiful. But I think it's got the reset ball thing. That was all I wanted to say. You guys doing a great job.
Oh, thank you.
It's like there's probably a lot of examples of everything.
Yeah.
I wouldn't say every permutation that we're going to go through is represented on the EMs in the hall, but probably a lot of them. Yeah.
It's kind of cool.
Oh, yeah, yeah. If we could just take the time to open every game there and kind of talk you through it.
You want it?
Yeah. So another stepper that gets reset, we'll call we're going to reset the count of players. So a lot of games will call this a coin unit, not the coin relay, a coin unit. So it's a stepper that it makes 3 steps. It resets to 1, and if you've added a second player, it steps up once. Add another player, it'll step up. So very short steps. I've worked on Gottlieb games that use a single pulse to reset it, and I've worked on ones that use 3 pulses to get it all the way back down. So it's again, not one answer, even in the same manufacturer. The games are very close together in years, but they had just changed the way they do that. Other games may use relays to keep track of how many players have coined in. This is kind of what we're talking about. So that's one of the things that needs to be reset. I think in general, these don't have feedback. And that's a lot of times why your game will reset, but you're in a multiplayer game without having pressed the replay button multiple times or coining up multiple times. And there are other things that can cause that problem as well. So it's not just that these didn't give feedback, but that's one thing to be aware of, is if you're completing reset but you're still in a 2-player game, it could be that reset sent the reset pulse to this stepper unit, and maybe it went from the 4th-player position to the 2nd player, or the 2-player position, but not all the way back to 0 or something.
Mm-hmm.
Any other thoughts on that one?
No.
Okay.
So the score reels are often getting all back to 0 is certainly part of reset, but it's something that seems to confuse people. The score reels all have 2 switches that indicate when they've gotten to 0. And the way they work is that during reset, the score motor is sending pulses in chains of 5. You may have heard on reset, dot, 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 right? That's a cadence from all the score motors where they're sending out 5 pulses to the score reels, and they're resetting in groups of 5. Each score reel will take as many of those steps as it needs to get back to 0. And one of these 2 switches, on this slide, it's called the run-out switch, opens when each score reel gets to 0. Its run-out switch opens, and that blocks any further pulses from getting in and advancing it past 0. So that's one of the 0 position switches. There's another 0 position switch that does the feedback that we're talking about, and that lets the reset circuit know that this score reel has done everything it needs to do. We're done with reset here, and we'll wait patiently for the rest of the game. So often you'll read, people having problems. Well, my score reels all get to 0 so that I know that they're fine. Well, that's just half the battle. I still have to phone home and let the reset circuit know, right? So I need both of these switches to be working properly. I think that's everything.
Yeah, the problems when either switch is not working as intended appear differently. If you watch a score reel reset and get to 0 and keep going a little further, it's the run-out switch that didn't open. And your game may reset sometimes and not may complete reset sometimes and not other times, because if it happens to be at a 0 at the end of one of the da-da-da-da-da, the other switch could be saying, oh, I've got 0 showing. When in fact, you would have to have ended a game with that reel in the 5 position or something. I'd have to think maybe 6. So you've got a problem. If the run-out switch isn't opening, you may run past 0. And if you see that, you know you're looking for that run-out switch. But if you're looking at everything as showing 0 and it's still running and you've looked at everything else, you may have you may have a game with 16 score reels, 4-player game, or more than 16 score reels. And if they're all showing 0, but one of them hasn't closed the switch that provides feedback saying I'm at 0, and sometimes that switch opens to give feedback, by the way. If just one of them is not doing it, your game keeps trying to complete reset. And it's just this one switch on one reel. And they're all showing 0. You just have to go look at that.
So these are score motor charts that you might see on your schematic drawings. And they're showing you when and how many pulses each of these switch stacks is throwing out. On the left is a Bally score motor chart, and on the right is a Gottlieb score motor chart. And the Bally chart is actually replicated twice. They would always put two sequences back to back. But you can see in the red boxes, these are the chains of 5 that they use to send out pulses during reset. Because in the worst case, all of your score reels are at 1, and it takes 9 pulses to get them back to 0. So that means that there's usually at least 1 pulse that's not used, right? You never use all 10 pulses, because if you're at 0, you're going to stay there. But this is, you will usually find these on this schematic. They didn't always include the score motor chart, but this would help you identify on what cam that switch is or where you would find it on the score motor.
And on some multiplayer games where there's a lot of score reels to reset, and you'll see this if you're playing the games in the hall. They each kind of do this differently, and they take a different amount of time. Gottlieb multiplayer games are not very fast at getting everything to 0, and we'll talk through what that process is like. But they're gonna set a bunch of reels to 0, set a bunch more reels to 0, set the last ones, and then they move on. There are some, I think it's going to be Williams games, if that's a Bally, Williams games. They've taken those 5 pulses and they have another 5 pulses that are sort of offset. The Gottlieb chart shows the capability, and I'm not sure if Gottlieb ever used it that way. But when you do a reset on one of the games that's doing that, the score reels just go, and they're just gone. They all are done. But they can't actually send 1 pulse to all 16 reels at the same time, or you would end up drawing too much current firing 16 reels all at once. So they'll do, I think they can do 8 at a time. So they'll do 8 and then 8 and 8 and 8, and it just goes so fast. It looks like they're all going at the same time, but it's incredible that it just like it's done.
So to see these on your schematic, these are the runoff switches from 3 different games. They have slightly different names. You kind of have to learn to recognize them, but these are the circuits that are driving the solenoid in the score reel or the disc unit. And it's always followed by, this is the switch that's on the score reel, and it's always right next to some switch that has something to do with the reset circuit, right? So in this case, the D relay here is a reset relay. There's a reset relay down here in this Bally drawing, and another reset relay in this Williams drawing. So the pulses are coming through that lower path and having to get through that run out switch to get to advance the score reel. And when I get to 0, that's the switch that opens and prevents any more pulses from getting through.
And a nice thing to notice about these 3 examples is you've got one line. If you're familiar with reading schematics, it's hard to kind of point to everything. There's one line that's the normal scoring circuit for getting 10 points or whatever it is that we're looking at. And the line next to it that runs in parallel going to that same coil is the one that does reset. So they're not happening at the same time. One of them is while you're in a game, and one of them is happening during reset. But they're driving that same coil, and it just depends on where are you in reset or doing something else.
So these are all examples of the runout switch that's blocking these pulses, but there's also examples here of the switches that have to then phone home and provide the feedback to the reset circuitry. So this top drawing here is a Williams drawing, I believe.
Yeah.
There are 16 switches here representing the score reels in a 4-player game that all have to open up before I'm allowing my reset relay to relax. So once reset has started, it's going to stay active until all 16 of these things have come through and opened up. So as David mentioned earlier, if any one of those fails to open, we'll never come out of reset, even though maybe all of my score reels have stopped advancing. I still need all 16 of these to open up too. And on the bottom is a Gottlieb example. Notice that their switches are normally closed, and the Williams ones are normally open. They're just different conventions and different circuit styles, and whether or not your switches are in parallel or series. So you need to really look at the schematic to figure out which way your switch has to behave on your particular game.
And in this case, I can tell you, the state of the schematic is the score reels are at 0. Mm-hmm. So again, in this example, Williams, when the score reels are at 0, the switch that's giving feedback is open. On Gottlieb, the switch that's giving feedback is closed. And they're both correct. It's just they do it differently. I have one anecdote to go with the Williams schematic, though it wasn't a Williams game, it was a foreign game I was working on. I lost hours because I didn't notice that where we see the 16 in parentheses here, representing there are 16 score reels that have to hit 0, it actually said 17 or something like that. I hadn't looked at that number. And that game was managing a feature of the game with a score reel that was mounted under the playfield. You couldn't see, there was nothing on the reel. It was just they wanted a 10-point stepper, and they buried it under and they documented it as a 17th score reel. And that's where my problem was. I had looked at all 16 score reels till I was blue in the I could not figure out why I couldn't finish reset. That number said 17, and I had to find the last one.
So this is going to an animation of what a reset sequence might look like. It's a simplified drawing. It just has 2 score reels. This is the score motor chart that we referred to earlier, and down here at the bottom are the coils that drive 2 score reels, and off to the side on the right are the images of the score reels. Right now it's at 37. The game ended with 37 on the last 2 digits. I've got a reset relay here in the middle, and when I put this in motion, what's going to happen is that the reset relay will fire because I've fired the start button, and that will make my motor run through this reset relay switch. And we'll see the pulses coming out from the motor and trying to drive both of these score reels. The 7 is going to get to 0 much sooner than the 3 will, and the 3 will require that this thing go through a second sequence. So right now you can see we've advanced 1 digit. We're about to advance another digit here. And when the circuit turns green, that's when it's conducting electricity. So this is the 3rd digit, and now my 7 has gotten all the way to 0, so that score reel is done. But I've still got this reset relay active because I know that I haven't gotten that 2nd digit. So I've gotten up to 8 now, and I have to, that's the first 5 pulses that have come out of my motor, so I'm going to repeat that process and try to get those last 2 pulses out. So we're going to step from 8 to 9 here, and then finally from 9 to 0, and that's going to allow my reset relay here to relax. And now the motor is just going to run by itself with nobody asking for it until it gets back to its home position.
Is this animation on your website?
Probably something similar.
Okay.
Yeah, I do have similar animated drawings.
It's really great to see it sort of slowed down. I guess if you're watching the recording of this, you could actually like stop it and kind of look even more closely between each step. But I'd love that you do these animated circuits where you can see how the pulses of the motor are energizing different parts of the circuit. It's hopefully a really good learning tool for people.
So moving on from that, back box lighting is the 4 score reels. All the scoring was done with lights, and it's typically done with 2 big steppers in the back box. Commonly 10,000 point stepper and 100,000 point stepper. And we'll try to step through what that looks like a little bit here. But there's an unusual situation where the stepper actually steps to what's called a -1 position, which is more sort of a reset position, and eventually steps back to 0. And we'll step through that here in a moment. Is there anything else?
I was going to describe the step through before you do it.
Okay.
Because I thought when I learned this, I thought this is so elegant. I love how they did this. So the way these games work is the 10,000 stepper, and that's the low score, right? The 10,000 stepper is a continuous stepper, and it really just counts from 0 to 9, and then when it goes from 9 to 0, it just keeps going around and around. When it goes from 9 to 0, it sends a pulse to the 100,000 stepper to step up. The 100,000 stepper is that's actually a bigger stepper. It has a lot of steps. It'll count up into the millions. So when you get to 900,000, it just does another step to get to 1,000,000. The next step is 1,010,000. Next step is 1,000,002. So it's a big stepper. And it resets with just like a snap. So when it snaps back to that -1 position, it has closed a switch that will run the motor and advance the 10K stepper until it gets to 0. When it goes from 9 to 0, this one, the 100,000 stepper advances from its -1 position to 0, and the 10K stepper is at 0, and now your score is reset. So the next few slides sort of walk through what's happening in the schematic that shows you that happening. I think if
Sure. So the first step here is it's
so small here, yeah.
It's small in both places, yeah. So the 100,000 unit steps has its own reset coil. It rewinds all the way back to its -1 position, which its 0 position, which will close this switch once that's a position on the stepper, which represents a closed switch, and that's what's going to fire our.
And some games will label that the -1 position. This labels it the 0, closed at 0.
Yeah.
C at 0.
So when you hit the button, this thing resets, closes that switch, and then that's what fires our reset relay. The reset relay then will activate this next circuit below it, which starts firing sends pulses to our 10K unit, and that's what's going to walk it forward to get back to 0. This one does not reset, it's like a score wheel, it walks forward to the next 0 position. And you can see down here, my 10K unit, my 100,000 unit, has to walk up from wherever it is, up to this 9th position, and when it gets to that last position, it fires that last step up, one pulse to the step up relay of the 100K unit, which steps it out of -1 and into 0. And now we're ready to start the game. And that is going to shut off all the other the reset relay and the other reset devices.
And you can sort of see this and hear it if you play some of the wood rails in the hall. As long as they have a score up, when you start a new game, you're going to hear a thunk and a ding, 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 and the lights are probably going to move through the 10K stepper, and you can actually see it happening if you look at that. If you're watching that while it's going. And now we get to when everything has finished resetting and feedback has been sent back. How do we end reset? Relays need to turn off, or trip latch relays then get latched or tripped. I never can keep track of what their nomenclature is going to be.
We're waiting for all the feedback that the game requires to come back from the rest of the game, essentially.
Yeah. So here's some examples. Let's see. So the Gottlieb example on the right, waiting to see that all they call them drum units, those are score reels. They're all at 0, and that's going to allow let's see, when they...
so the D relay is waiting for all of...
oh, I'm sorry. I was looking at this one.
That's the Bally one.
Yeah, that was...
The Bally's on the right, yeah.
Let's see.
So these are going to keep my reset relay above it active until all of those open up.
Yeah.
Right. But this is just examples of this, the kinds of feedback that you're going to see. The switches that are going to keep the circuit active until they have accomplished what they want to. A more elaborate game, I think this might be Grand Prix, has 20 score reels that it waits for, but it also waits for 2 different bonus units to get back to 0. So it's got a number of more, many more switches than most games that all have to close for this thing, or all have to open for this thing to come to the end of reset. If you have a late model Chicago coin or early EM Stern game, you may have this score reel with a wiper arm on it. I don't know if you've run across these before. These are kind of problematic, and be careful if you're shopping for a game.
We should say, there are a lot of games that have a wiper on a score reel. What's unique in this situation is they depend on that wiper for the 0, the run-out switch, and the feedback switch, and the 9 switches there too. And so just seeing a wiper there is one thing, but in these Chicago coin games, the other switches aren't there. It's all wiper.
It's all wiper.
And there are some issues that can come up with that wiper.
So the wipers are all mounted on this plastic arm, and many of these plastic arms have warped or cracked, and so the wipers are not making good contact anymore. Some of these games, it's not shown in this drawing, these are solder lugs, but some of these games actually have edge connectors, PC edge connectors that connect to the score reel cards. So not only do I have an often compromised connection through this wiper, I have an often compromised connection through the edge connector. And to make things even worse, I have to get all 16 of them in series. So there's 16 switches end to end to end to end to end to end, plus possibly 2 more connections per edge connector. So there's another 32 connections there. Even when they're all closed, you may have enough dirt and grime on your thing that the resistance is enough to keep the coil from firing. So there's all kinds of things that can go wrong with these. And they use the same wire color between all of the 16.
It's a cautionary tale. I mean, the games can be made to work.
Yes.
but getting parts could be a challenge if you've got something that's so warped you can't adjust around it.
It takes a fair bit of patience and it builds character.
As if the rest of this weren't already difficult enough, we'll throw a wrench in the works with that.
So move on then.
Yeah.
So Gottlieb in the early 70s for their
I think they did even earlier, actually.
they went from, in their multiplayer games, they went to the device called the player unit, which is keeping track of both the ball in play and the player up, as well as first ball, last ball, things like that. And it's if you've ever reset a Gottlieb, late model Gottlieb multiplayer, you've recognized that cadence, that loud click, 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 clack, 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 in pulses of 5, as it's going through and walking through and resetting score reels and whatnot. And there's a lot of math that's going on. There's a lot of switches and a lot of positions on this thing. It's I believe, a 30-stepper with something happening in most of these steps. And to get ready for this talk, I actually tried to unwind one in my head. And what I came up with, looking at my sample size of one game, this is what I came up with. The various positions on the step unit have very specific functions. So the first 20 positions on this thing are strictly for tracking the ball in play and the player up. So for example, position 0 to 3 is ball 1 for each of the 4 players. And the next 4 positions are ball 2 for the next 4 players. So if you've ever...
I was just going to say, you can see this while you're playing the game. If you're on a multiplayer Gottlieb game and you're playing a one-player game, when the ball drains, you'll see it. It's going to light player 2, light player 3, light player 4, and then go back to player 1. That is it skipping over the other player's steps. It can't jump ahead. It has to go through each step. Mm-hmm. Is that what you were going to say?
Yep.
Probably? Yeah.
Yep.
Okay.
So it knows how many players have paid, and it will skip over any players that aren't playing the game. So the first, from 0 to 19, those are all positions for somebody's playing some ball and some player. But when I get to position 19, something called the last ball interlock relay fires, and that's what triggers game over. If I haven't, it happens earlier naturally for a 3-ball game, or for a single player. Position 19 is for a 4-player last ball. But that last ball relay can trip anywhere in this thing. But the point is, when I get to game over, the game has ended, right? It's sitting there, potentially scores on all 4 sets of score reels. The reset sequence to get back to starting a new game is what trips up a lot of people. It's a pretty complicated sequence that we're going to step through here in a minute. At a high level, what's happening is that I have to get from wherever this game ended to position 20. So position 20 is the one where I start to reset score reels. So maybe I ended a 3-ball game, or maybe I unplugged it. I could be anywhere from position 0 to 19. Not knowing how that game before me ended. So I have to walk this thing up to get to position 20. At position 20, the player unit stops, and suddenly the player 1 and player 2 score reels start to reset. And they reset and take as long as they need to. And when they're done, this thing will take a step to position 21, and it will repeat that process for players 3 and 4. And then it has to walk its way back to position 0. Now, it may do some things in other games. In the game I looked at, there was nothing really interesting happening from positions 22 to 29. So it's just trying to walk its way back to position 0, where we pick up again player 1, ball 1. Okay? So to illustrate that, this is the generic drawing that's for the... Here on the left is the add player unit coil. Where's my, here. So that's the solenoid that's going to advance this stepper, right, this 30-step stepper in the back box typically. And that's the guy that has to walk through all of these positions and accomplish all of these things. And if you're stuck in reset and you can't get through it, often what you can try is go to the back box and manually push in the plunger on the player unit and see if it'll pick up what you've done is you've allowed it to skip a step and see if it'll pick up and run back to position 0 from there. But to get the ball, to get things started.
Well, one thing I like to make sure people understand, especially when you're looking at this, let me see if I can get that. So,
Oh, yeah, so this,
you know what I'm going to
this circuit here is actually serpentine, right? It's winding back and forth because it's so long.
Yeah, your schematic is typically showing sort of a power rail on this side and a power rail on that side, and something happens in between. To prevent it from being this wide just for this circuit, they run it back and forth. But really, just picture that as a longer line between the two power rails. There's nothing special going on here. It's just a really long line. And if you look at the normally closed on Z1 and Z2, that's the path that you're following when you're in a game. The run-out switches that are shown parallel to that is more what you're using when you're trying to reset a game. At Z1 and Z2, get energized at different times and open that switch. I don't know if that's,
We'll walk
it's
through that
hard
here.
to, okay, you're gonna walk through it.
So to start, when you press that start button, what happens is the S relay fires, and that brings up my score motors to start running. And this is the path in red that's being exercised to get my player unit to walk forward to find position 20, okay? Because I could be anywhere from 0 to 19, right? I need to find position 20. So initially, I am getting, these 5 pulses, right? This is a motor 1A switch, and I'm getting these 5 pulses coming out of the score motor. And they're flying right by all these switches and taking this bypass through Z1 here and through Z2 switches here, and just walking that player unit forward, okay? When I finally find, when a separate reaches position 20, whoops, I went the wrong way. When I get to position 20, the stepper actually closes this circuit here, which fires my Z1 relay, which means I'm going to stop that stepper for a minute and take the time to reset the player 1 and player 2 score wheels. With Z1 fired,
We should say that switch will then open. It's not, yeah, that switch opens. This was not a schematic you created, so we couldn't change it, but.
I'm just coloring the same schematic over and over again, yes. So when Z1 fires up there, because I'm in position 20, I open the switch in the red box below, and that kills my bypass path. I now have to actually do the push-ups to get all these score reels down here to reset. And so the motor starts throwing, it's still running, it's throwing pulses at these score reels, and gradually, one at a time, they reset. And once they've all reset, the pulse from this 1A can finally get through this long path and advance my player unit. Well, it's going to advance to position 21, right? And the same thing is going to repeat. Now I'm in 21, and now Z2 is going to close instead of Z1, which is going to open up this thing that we were using to bypass. So I can no longer bypass around 3 and 4, players 3 and 4. I actually have to pause there and reset those score reels, sending all the pulses through that way. So you can see here I'm bypassing the lower player 1 and player 2 switches, but I'm having to do my push-ups and get through player 3 and player 4. Once that finally, the score reels all reset. The player unit picks up again and freewheels its way back to position 0 using the switch in the red box here is P5B. It's one of the switches mounted to the player unit, and that will bring me back to 0 position.
Stepping past those steps that don't do anything.
Right, and that so the way the schematic was drawn in the original drawing is that it was drawn in player 1, ball 1. So that's how all the switches are drawn, because all these score reels have now been reset. And I'll present here an animation of this schematic. There's it's a bit abbreviated, but what's going to happen is that I've got, on the right side again, I've got score reels that have to be reset. And it's going to take me 3 cycles to get through this. And right now, I've got this player unit shown that is in position 19. So I'm at the end of the previous game. The first thing that has to happen is I have to step down to position 20, and then I will reset 1 score reel, and then step to position 21 and reset the other score reel, and then find my way home again. So we start off with the player unit just now stepping into position 20, and now I'm going to reset one of these score reels from 8 to 9 and from 9 to 0. And then that's going to let the player unit take another step from 20 to 21, and then I reset the second score reel. And now with both score reels reset, the player unit itself is going to have to walk its way back to position 0. I've cut out positions 24 to 29 to save time, but eventually I would get back to 0 and this game would be ready to play. So that's most of the highlights that we wanted to cover for resetting. Let's talk briefly, with a few minutes maybe, about common failures and what you might do to evaluate them.
So, if you're pressing the replay button and nothing happens, what could the problem be? Well, you might have a problem with the button. You might have a broken wire or a switch isn't closing. But more often than not, you either don't have credits or you haven't set it to free play somehow. There is a Jones plug that plugs the door in. You got to make sure that's in position. The ball count unit at 0 is a really interesting one. There are Gottlieb, I don't know if this is what we were thinking when we put this bullet on. There are Gottlieb games where if you've taken the ball out of the game and you reset, or it's got, the situation I often face is the ball got stuck on the playfield, someone hit the replay button, and the ball count unit went to the 0 position, which is kind of a reset position. It's not ball 1, it's before ball 1. It advances when the ball is put into the shooter lane. It rolls over a switch. The ball's stuck on the playfield, you've hit the reset button, and it has done a reset, but there's no ball to move it to ball 1. The game seems broken, so someone turns it off. Now when you turn it back on, you cannot get the replay button to work because the ball count unit is at 0. It'll never work. The coin switches work, but the replay doesn't. It's just the way the game is designed. So I've had games where if the ball gets stuck on the playfield, this is at our museum, so ball gets stuck on the playfield, it won't start, and I've trained our staff, if that's the situation, you can either coin it or, I mean, you're not going to go in the back and try to fix it, but I think that's what we were probably putting it in there. It's a very weird special case where you got partway through a reset and you just can't be able to finish it now. And that's why you say, check there's a coin unit. Does a coin chute or a coin switch work? That'll often overcome some of those problems.
And this would be a great situation to break out your alligator clip jumper, and you can jump around various switches in this circuit to see what you can do to make it go, and that would identify for you which of these switches isn't closing. The score reels start but don't finish. It's only a partial reset. This is a circuit we saw earlier. It may be that some of these switches are opening too soon. They're not staying closed long enough to keep your score advancing to 0. That would be a common issue. The SB armature, we talked about it at the beginning. If that switch is not opening and closing it as it should be, you would never get through. It would keep trying to reset that bank thinking that it hadn't completed its own reset yet.
I think I've often had it where everything actually has reset, but this switch hasn't closed, and it won't fire.
Okay.
It's kind of both cases cause you to not be able to finish.
Or your fuse could be bad. In the red box, there's a fuse there that's dedicated to this bank, right? If your bank isn't resetting, in this situation, it might just be the fuse too.
Yeah.
Okay, so my score reel's reset to 0, but score motor keeps running, right? This is the second switch on the score reels that needs to behave properly. This is the feedback switch. And if somehow my feedback is not getting back to my reset circuit, the motor will keep trying, thinking that you haven't gotten there yet. So these are two different manufacturers' approaches to using those zero position switches to end the reset sequence.
I think we ended up talking about most of these as we went through in the beginning as well, because the bonus unit we've talked about, it's going to have it more often than not has a zero switch that's sending some feedback, and even if it resets but the switch doesn't end up getting closed, it doesn't finish reset because of one switch not closing.
In this scenario, you would see a bonus unit that had stepped down to zero and kept trying to reset itself, and kept getting pulses to reset some more. And it's because of that switch hasn't done its job.
That actually was that comment made me think of something. If you find that your game is stuck in reset, and you keep getting pulses to the bonus unit to reset, it doesn't mean it's the bonus unit that's causing the problem. It's like the motor is not, it's the victim, not the culprit. The bonus unit is going to keep getting reset pulses while you're stuck in reset. It doesn't mean that it's the problem. Something else could be the problem, but when you're in reset, all this stuff all the circuits are made to complete reset. So the ball count unit could keep trying to reset, the reset bonus unit will keep trying to reset. That's not necessarily where your problem is. They're all going to keep trying.
In this drawing here, the reset seems to complete, but nothing scores. There are different quadrants and different sections of your schematic. One part of the game is often turned off entirely once the game has ended, or if you've tilted or something. That makes your playfield kind of go dead. But the circuitry that has to deal with reset and coining, starting a new game, that's typically always live. And these parts of the schematic are often separated by these switches in the red boxes. These are the power rails that are coming off of your transformer. And there can be 2 or 3 or 4 switches in that power rail that provide power to the top part of the schematic, or the part that's used for playing. So if your game does reset, but your playfield won't score, or your flippers don't work, it may be because one of these switches on one of these relays hasn't closed again to provide power to the whole game. We talked briefly about the player and coin unit at the beginning. If your game starts up and resets just fine, but it always starts a multiplayer game, for example, that's because one of these units, the coin unit or the player unit, has not reset back to zero. That's one of these are the devices that don't provide the feedback. So they get a single pulse, and they have to make the best use of it, and if it's gummed up or binding somehow, it may not reset and get back to zero. So your score reels all do the right thing, but this thing will always put you in a multiplayer game because that stepper hasn't come back. If you're lucky, your game comes with a manual, and your manual has a complete reset sequence in it. A lot of people overlook the game manual, but this is for a Valley game. You'll often find them in Williams games as well, and even in some even Gottlieb manuals will have some of these. But this is a very detailed step-by-step sequence for this particular game of what reset should look like. So often when online, when we get a question about, my game gets, doesn't finish reset, well, if the game has a manual and the owner has the manual, we'll say, well, how far does it get through the checklist? And that's where we can start to troubleshoot. So this can be invaluable if your game has that kind of documentation.
And there are some other resources that we can point you to for further learning of startup sequences. There's a good book available from Pinball Resource at pbresource.com. I don't even remember. If you look at the area where he has books, you'll see a book by Hank DeJager. I don't remember the title of it.
I don't remember the title
We didn't
either.
put that in the slide. We just call it the DeJager book, yeah. We showed an example of some game manuals. There's a website called pinrepair.com that has a lot of information for repairing EM, electromechanical games, as well as other kinds of games. But it does have a breakdown of some startup reset sequences. Mark's website, funwithpinball.com. You have information there. And the online repair clinic. So when you get to that website, I think it's under events and clinics.
You can, you'll find information about the clinic. You can also add yourself to the mailing list if you'd like to hear about upcoming clinics.
Yeah. And I mean, people have talked on Pinside for years. There's more and more activity in different groups on Facebook now where people are seeking out help with solving all kinds of problems on their games. And now we're already over time, but if we have a couple of questions, we could probably field them, or you can catch us later.
Questions, anybody? I'll pass a mic around because we are recording this, and this will be on our YouTube channel for Mark of Pinball.
And thank
Any
you, Emoto,
questions?
for putting all these together.
Yeah, thank you all. It's exciting.
So you can see if your game isn't completing reset, we don't. There's no simple answer. It would be nice if we could just say, oh well, then look here. But yeah, there's so much that it has to accomplish to get here. It's not simple. All right.
Thank you.
Oh, we have
Wait.
a question. Well, thank you.
Just wait, one question.
Thanks, guys. Just one quick comment. The book is called Manual for the Repair and Maintenance of Electromechanical Pinball Machines, 1960 to 1977. And it is available, if you want to take the trouble, at the internetarchive.org. And it's available there as a PDF
Okay, yeah.
if you
I
have
was
lots of
remembering.
paper in your
I
printer.
couldn't remember where that was, but yeah.
It's a
Internet
very
Archive?
big book.
Okay,
Thanks for that extra info. That's awesome.
yeah.
All right. Oh, yeah. Hey.
Mark, you had a slide that was showing the steps for the player unit.
Yes.
Is that anywhere? I have not seen that before. Do you have that out on your website somewhere?
Not yet.
Okay. It was the
That
0
was
through
for this
21?
presentation, and eventually it will find its way to my website, but
Okay.
yeah, that one, right?
Yes, that one, yes.
And again, you said you did this looking at one game.
That's one reason it's not on the website.
I can help you. We could look at a few more and just see, did other steps get used, and is there some commonality in that?
But that's a big topic in itself, the player unit. It's a big gnarly beast, and this is just an introduction to the player unit.
We could do a whole other hour. I think we're wrapping it up. Thank you, everybody.
Thank you.
Thank you. Thanks, y'all. All right, hope y'all are enjoying your Golden State Pinball Festival 2024. It's Sunday. It's the last day.